Okay, so in this question we're working with a pyramid that has a pentagon as a base, and we're given the height of the pyramid. What is it? The height of the pyramid is? Told the height of the pyramid is 8.1 centimeters. What does this height represent, this 4 centimeters?
Radius?
This height represents the height of the triangle that's inside the base of this pyramid. What shape is the base?
Okay, so my name is Mathusan Kasinathan, and my answer is triangle.
No, it's actually a pentagon. Okay, but you're right. It's made up of triangles. How many triangles are on the base? Yep.
6.
1, 2, 3, 4, 5. So how are we going to find the total area of this pentagon? Yep.
You find the area of a triangle and times it by 5.
Good. So we're going to find the area of one of the triangles inside this pentagon. How do you find the area of a triangle?
Base times height divided by 2.
Okay, so what's the base?
5.8.
And the height of the triangle?
By 4 divided by 2.
Okay, so let me know what you get for the area of one triangular.
Let me know too so I can say it first.
Okay, so the area of one of the triangles inside the pentagon is 11.6, and there are 5 triangles. So we have to multiply by 5, and what do you get? Approximately 58 centimeters squared. This is the base of the pyramid.
Miss, you're recording.
Sorry, I meant of the pentagon.
Miss, your base times
Okay, the
height.
original question asked us to find the volume of this pentagonal base pyramid. So we need to know the formula for volume of a pyramid. What is it? Okay, so in order to figure out how much space is occupied by this pentagonal base pyramid, we need to find the area of the base, which we did. We found the area of the base, and we have to multiply it by the height. Do we know the height of this pyramid?
Yes.
And then we're going to take that and we're going to divide it by 3 to figure out the total volume. So let's do that on the next page. Good. The area of the base was 58 centimeters squared, and the height of the pyramid given was 8.1, and we need to divide that by 3 to figure out the total volume. What's the total volume of this pentagonal-based pyramid? We want to fill up this lamp, and we know the lamp, the space occupied inside the lamp is 156.6 centimeters cubed. If 1 centimeter cubed equals 1 milliliter, how many milliliters would this be equal to? 156.6 milliliters. The question says that you have 750 milliliters of oil. We want to know how many times can that go inside our lamp. We're going to take 750, because that's the total amount of oil we have, and we're going to divide it by 156.6. What do you get?
You get 4.78. If you round, it's 5.
Okay, but would we round up in this question? The question says how many times can you fill it up?
Oh.
Okay, right. You only have enough to fill this 4 times, and you'll have some oil left over. You'll have how much left over?
What is IMES?
0.78 milliliters left over. Good. In this question, they're asking us to figure out how many times can we fill up this cylinder using the cone. So if the cone were full, how many times can you pour it into the cylinder? What formula are you going to use to calculate this?
You use volume?
Right, we need to find the volume of the cone and the volume of the cylinder. What's the formula for volume of a cone? Pi r squared times the height divided by 3. What does r stand for?
Radius.
Do we know the radius in this question?
Yes.
Good. Radius is 4. Do we know the height for the cone?
Yes.
Good. We can calculate that. What is the formula for a volume of a cylinder? Pi r squared times height. Again, do we know r? Do we know the radius of the cylinder?
Yes.
Do we know the height of the cylinder?
Yes.
Can we calculate the volume for each?
Yes.
Okay, so when we calculate the volume, we have to remember to use BEDMAS, which means that you have to calculate the radius squared first for each one. You want to solve your exponents first. And we find that the cylinder holds 1,005.31 cubic centimeters, and the cone has 167.55 cubic centimeters. What was the question asking you to find? We need to know how many times we have to fill this paper cup in order to fill up the cylinder. Good. We're going to divide the volume of the cylinder divided by the volume of the cone, and we end up with approximately 6. So therefore, you have to fill the paper cup 6 times in order for it to fill up the cylinder. And that's how you solve this question.